Let us discuss about a new machine that is ball mill or otherwise called as pebble mill. What is this ball mill or how it is constructed? Let us see. This ball mill has got a milling chamber which is like a vessel and got a lid for that. This entire chamber can be closed by the lid during operation. So you can see the lid as well as the chamber over here. This is a metallic cylinder because it needs a tough and hard surface and it should be resistant to any sort of forces. Inside this chamber we put the material for size reduction. You can see the feed material is marked over there, and additionally you put some steel balls into it that's occupying 30 to 50% of the space. The steel balls and the materials are fed together, and the entire metal cylinder is connected to a rotor that is connected to a motor further. So the milling chamber or the metal cylinder keeps rotating during the operation. That tumbles the entire things inside, and the steel balls will actually cause size reduction of the feed material. The principles, if you see, the mechanism or the method of size reduction happening is nothing but impact and attrition. So it's a combination of impact and attrition that causes size reduction over here. It is not a single mechanism as we saw in the previous equipment. So as I was telling, the working of this particular machine is like around 60% of the volume will be filled by the materials and the balls, and the entire metal cylinder will be rotated at a particular RPM, and the size reduction will take place. Now here there is an interesting thing to look at into the something called as critical speed, which determines the size reduction in a ball mill. What is this critical speed? See, there are three examples shown here, A, B and C, which represents the rotation of the ball mill at three different speeds. So this is a cross-section view of a ball mill. You can see the metallic cylinder over here. This is the metallic cylinder, and you can see the balls inside. So when the ball mill rotates in this direction in a slow speed, the balls simply will roll one on the other, and this rolling will not cause effective size reduction of the material inside. Let us increase the speed into very high speed. What happens? At a very high speed, the entire balls inside will get a high amount of energy and a high amount of angular velocity or something, and it just keep rotating adhering to the wall. So it has now nothing to do with size reduction. Let us look into the third example, or the figure C. Here in a moderate speed the cylinder is rotating and the balls are lifted up slightly, and further from the height it falls down back, and again it is lifted and it falls. So this is something called as a correct speed, or otherwise it is called as critical speed of ball mill. This critical speed, as we said, it is very critical because only in the correct speed or critical speed it can impart both the mechanism of attrition as well as the impact. So when the balls roll over the material, it creates attrition, and when the balls fall and hit the material, it creates impact. Look at the various types of balls used here. It can be a round ball, banded ball, cubes, and cylinder rods can be used instead of balls. And the major advantage is this particular machine, since being a closed system, it has got a lid and a cylinder. It can be used for sterile operations. The entire chamber can be sterilized, and it is used for fine grinding of particle size 100 to 5 millimeters or even lesser than that.